Alright, we've practiced making Lewis structures using bingo chips. Now I'm going to teach you the steps to do it without the bingo chips, so just a pencil and a piece of paper. So here's the steps. Go ahead and pause the video, write these steps down in your notebook, and then we'll come back and we'll write a couple notes in between the lines. So in the next video, we'll actually practice using these steps. Right now, we're just writing them down. I'm going to talk about a couple additional things. So when you're following these steps, make sure that you're also following the rules that are written above them in your notebook. So things like the least electronegative element is in the center, cations and anions, add and subtract electrons. But I want to talk about step number 4. So step number 4, try and satisfy the octets of the atoms by distributing the remaining valence electrons as non-bonding electrons. So once you set up your structure, you would put single bonds between all of the elements, and then you would use your remaining electrons, so what's left over, to try and satisfy the octet. So you do that with lone pairs. But there is 2 sub-steps then. So let's say you get to the end and you find out that there's too few electrons. There's no way to satisfy all of the octets with only single bonds and lone pairs. If this occurs, that means you're going to have to use multiple bonds. So multi-bonds, so that would be double bonds or triple bonds. You do that by taking one electron from each element and then putting them into the middle. And also, something that we have not seen yet is too many electrons. So if you get to the end and it turns out you have more electrons than what you need, everyone's got the octet, but there's still some left over, that's what's called the expanded octet, and we will talk about that. So this expanded octet is a special exception to the rules. And so with an expanded octet, you wind up with an element that has more than 8 valence electrons in a Lewis structure. So you get to the end of step number 4 and you have too many electrons. So you have more electrons left over. That means those electrons, those extra electrons, are going to go on the central atom. And we'll see some examples of this in the next video. It's going to look a bit funny at first, but if you follow the steps, you won't have any problem identifying the elements that have an expanded octet. And there's also what's called the incomplete octet. So one example of the incomplete octet would be hydrogen. Hydrogen only needs 2 electrons, 2 valence electrons, so 1 more. There's some other exceptions as well. One of them is going to be beryllium. Beryllium has 2 electrons, but it only needs 4. And so that means it can form 2 bonds. And then the last one is boron. So boron needs 6. And so just like rule number 2, if you look in your notebook, hydrogen only needs 2, so a single bond would be all it needs. Beryllium, which needs 4, is going to need 2 single bonds. And boron, which needs 6, is going to need 3 single bonds, and that is it. All right, that's a brief intro to the steps. We're going to go through and practicing them, and that's the best way to learn how to do this.